started the Camtasia recording. I'm starting the Zoom recording.
Recording in progress.
All right, I've started the Zoom recording as well. All right, so what is the topic for today? Before I start anything, I have some throat pain. I'm actually struggling to speak. So if you guys hear any problem understanding me, please do repeat one more time. Just ask me to repeat one more time. And also maybe if you're not able to hear me properly, just ask me another time. I'll be repeat the thing. Okay. So the topic for today, we'll be continuing learning the transactions, okay, and transaction Spring, which is a very important topic, and maybe a topic that we usually struggle because we do ignore it, but it's a very important topic, as I have said you before. So in the last session, we were discussing some annotations that's called transactional annotations. If you guys remember, we keep on annotating our methods with @transactional, and we spoke a little bit about the propagation label. But if you want to see something else here as well, if you're going to do a control space, you're going to see something called isolation. And there are a lot of different values over here, and it really can mess things up if you don't understand this one. So we'll be take time to understand this different isolation labels and how we'll be basically, implementing all these things like read committed, read uncommitted, repeatable read, serializable. Maybe these things sounds familiar if you do remember your BTech days or in your engineering days, maybe 10-15 years back, or maybe 5-6 years back if you remember things, or else we'll start from absolute scratch. Okay, so before we come to Spring and utilize all these isolations labels which are present, I'm going to take you back to maybe your learning days, and maybe you used to learn a lot of different things, right? Those things we will understand with some presentation as a prerequisite before we jump into this transactional annotation and keep using all these things which are available. I want you guys to understand what do you mean by isolation. If you forgot it, or if you want to refresh the concept, we'll just revise it one more time, then we'll come to Spring. So for now, I'll be just closing my STS. We will not be reading it. I have prepared a small presentation. I hope that, I haven't checked the things, any typo, any spell checks. I haven't done, I just have written it. So maybe I think this will make sense. And I have written down some commands here. I'll be giving you this command, so make sure to practice these things as well, okay? So now come back to isolation, okay? So maybe let's start talking about isolations in ACID. If you remember, you have a property called ACID property. You remember? Atomicity stands for A, C stands for consistency, I stands for isolation, and D stands for durability. Okay, maybe today I will be exploring isolation in ACID, and this is one of the very important things. What do you mean by isolation? Okay, you guys remember about atomicity, A of ACID. Atomicity means, you have a bunch of queries. Those queries need to be executed, and if anything's in between fails, then the entire transactions will be rolled back. So either all or none. Either all the queries inside a transaction will be executed, or if something is failing in between, then the entire transaction will be rolled back. That's what we mean by atomicity. Now let's come to the isolation property, ACID. A stands for atomicity, C stands for consistency. We'll be going back to that. Now I want you guys to understand the isolation property so that we can utilize the things that we'll be learning from here in our Spring, and we can see it in action. Okay, so imagine you got some data. Okay, you got some data 10. Imagine this is some column in some table in your database, right? Now you got a transaction, let's say transaction 1, and this transaction is reading the data, right? The data, let's say this data is there in your database, and we are reading this data using the transaction 1. Now, imagine it is doing some read operation or something. Let's say read of data, then the transaction 1 will get the value called 10 because the data value is 10, and if you're going to read it, obviously it's going to give you 10. Absolutely fine. You can do read, write, or you can change the value as many times as you want. Things will work very smoothly if you got one transaction. But in real time, this will not be the case. you have to deal with multiple transactions. Imagine there is another transaction called transaction 2, which is dealing with the same data, right? Now, transaction 1 is also accessing the data and is reading the data, and transaction 2 is also, let's say it's doing some operation, like, it's first reading the data and then is writing something. Let's say data is equal to data plus 30, then this 10 will be changed to 40. Okay, 30 plus 10 will be 40, and it is going to write the data and it's going to override this guy, right? 10. So it will be, let's say, 40. Now transaction 2 changed the data which was previously 10 to 40 by performing all these operations. Now the transaction 2 has been done. Let's say there is another transaction called transaction 3, and now the transaction 3 is again accessing the same data, right? And imagine it is just performing some operation. Again, it is reading the data, it is adding more 20 with the existing thing, and then it is writing it, and now you can see the data value here. This will be overridden to 60, right? So you can see there are multiple transactions, right, which are occurring, and we have we have went from 10 to 60 by different transaction, modified the value, and things are looking very smooth, isn't it? Because I first executed the transaction 1, then the transaction 2, then the transaction 3. But this is not going to be that much smooth, okay, in your real time, because obviously these things will run parallelly, right? It will not be a cakewalk, like, first transaction 1 is running, then the transaction 2 need to wait, and once the transaction 1 completes, then the transaction 2 run, and then the transaction 3 runs. Like, these are like, running serially. But that will not happen. This guy will run parallelly, and that's where that's basically where we're gonna have issues of data inconsistency. I'll show you how. Now you can see multiple transactions trying to read and write the same piece of data. This is what I want to tell you. There are 3 transactions, and they all are reading a same piece of data which are available. Now imagine I have a product table here, and now imagine this is some quantity, like, there are some product table like product name, price, and quantity. I have a product called pen, price is 10 rupees, and let's say quantity is 50 stocks are available in my warehouse. Okay, just like that. Marker is another product, and the price is 20, and the quantity, there are 100 stocks are available for marker product. Now imagine there is a transaction 1 which is reading the value of 50. There is another transaction 2 which is reading the same data, 50. Now this is the thing, if we execute more than one transaction on the same data, as you can see T1 and T2, there are a couple of transactions running on the same value, and this is what we call a concurrent transaction or transaction concurrency, because couple of transactions accessing the same data item, right, which is 50 here, and this is what we call the concurrent transaction. And you understand already the data inconsistency problem will be brought by this concurrent transaction. Okay, why? Because the T1 will run, then the T2 will run, and then again the T1 will run, then again the T2 will run. If they will run in parallel, like, they will run like this, sometime T1 will run, sometime T2 will run, and they will run in parallel. The CPU will not sit ideal, the CPU will switch. Sometime it will run T1, sometime it will run T2, and that is basically a parallel. The transaction will run in parallel. But if the transaction will run in parallel, they will be brought to the data inconsistency problem, because imagine T1 is writing the data 50. Now same time T2 is just reading the data, and then the T1 rolls back the value. Okay, let's say T1 is making some write operation, it's changed the 50 value to 70, and now the transaction 2 is reading the 70 value, and now T1 rolls back. Now T2 is still using the 50 value which has been changed to 70. Then the data will not be like, the data will be changed frequently. If couple of things are reading the data in the same time, that will basically brought us the data inconsistency problem, because couple of transactions will run in parallel. The CPU will sometime execute this or sometime execute this, just like your threads. Okay, and what we're supposed to do is, instead of running them in parallel, theoretically imagine first we'll complete the transaction 1 and then we'll complete the transaction 2, and in practical they will run simultaneously. But we will do something just to make sure that transaction 1 first complete, then the transaction 2 complete, or transaction 2 completes, then the transaction 1 completes. And the question is here, can we run this transaction in serial instead of running them in parallel, which is going to bot us the data inconsistency problem? Can you run them in serial? Like, once we complete this one, you do whatever you want to do with this value, then give me a final value, and that value will be then again will be processed by T2. If they will keep using the same value, then it will be a problem, it will be a mess, right? So this is what I mean by the parallel transaction. And as you can see, the data will sometime used by transaction 2, sometime by transaction 1, then sometime by transaction 3. But this will not go that much smooth. Imagine first this line is getting executed, then this line of getting executed, then this line is getting executed, then this couple of line getting executed, then this line is getting executed of transaction 2. And here comes the problem. And this particular thing will leads you some read problem. Whenever you're going to read data, you're going to be getting inconsistent data. Okay, and that's where the read phenomena comes. And here you got different types of problem. Whenever you will be dealing with multiple transactions together, you're going to be seeing different types of problem, okay, while reading the data. What kind of problem? One is called dirty read, one is called non-repeatable read, and one is called phantom read. Okay, phantom means ghost read. We'll understand what all these read problems are. So we got all these problems that we'll have whenever we are dealing with multiple transaction, and multiple transaction are changing some data. And at that time, when a particular data has been read by many different transactions, we'll have all this problem. And to resolve all this particular problem, we got something called isolation level. That means we can control, if you're gonna see here, we can control, like, okay, transaction 2, whenever you are running, the transaction 1 will not see what is the value that transaction 2 is modifying to this data. And when transaction 1 is running, transaction 1 can decide whatever, let's say transaction 2, you can see it is modifying the data, let's say 30, one second, it is adding 30 to the existing data and making it 40. Now transaction 2 can decide whether this data it has changed, the transaction 1 should see this data or not. Okay, and the transaction 2 have the complete control, like the data that it is modifying, those data will be seen by the transaction 1 or transaction 3. So we have the complete control to isolate the transaction 2 from the transaction 1, or to isolate the transaction 3 from the transaction 1. They all can run in serial in an isolated way. Okay, in quarantine, like you guys used to have quarantine, right? You need to isolate yourself from different people. Like this transaction 2 will run differently, transaction 1 will run isolatedly, and transaction 3 will run isolatedly. And we will be understanding whatever how the isolation, what are the different isolation values we can have, and how we can control all these things, how we can decide, like transaction 2, whatever the data it is modifying, is that data will be visible to the transaction 1, and if transaction 1 is changing the data, then that data will be visible to the transaction 3 or not, and blah blah blah. Okay, we'll see these things. Okay, now can I show you something? Okay, maybe first of all, okay, this makes a little bit of sense, guys, little bit of sense. Like, can you just confirm it's making a little bit of sense?
Yes.
Yes.
Okay. Yes. Okay. Prashant, got a question or something?
Yeah, hi Vilas. Yeah, I just wanted to ask if you can just give me a brief summary. Like, I just joined. If you just give me a brief summary.
So brief summary here is Prashant. Like we can whenever we're dealing with one transaction, it is a cakewalk, right? Because one transaction can change the data and it can read the data. We can do any kind of read or write operation on a particular data. But when many transactions are available and they are running concurrently, like they are running parallelly, then the values that we have, we can have a mess. Because imagine transaction 2 is writing some data, transaction 1 is reading the data in the same time, transaction 3 is also right now adding something to the data. Right now the data will be keep on changing, and the values will be inconsistent throughout the different transaction. You know, right? Threads, right? Imagine 2 or 3 threads are running on a particular object and it keeps changing its value, right? Then it will lead us to the data inconsistency problem, right? And that particular problem, whenever we're reading the value, we can have different problems like dirty read, non-repeatable read, phantom read, and we'll understand right now, what this particular people basically means and how we'll be basically solving all this particular problem using some isolation level. This is gonna make perfect sense right now. Let me just show you some things practically. Okay, let me open one terminal window. Imagine this is my session 1 or this is my transaction 1. First of all, I want to connect to my MySQL database. I have written some commands. I'll be giving you this particular commands. I will just want to log into my MySQL terminal. I'll do command ++ and I'll clear it by hitting Control L. And now imagine I want to show the databases, and you can see I have this many databases. I want to go to one of the database called test db12. If you can see, I have created a database called test db12. I got a table here called product, right? And I got these are the data that I have inside the products table. Now imagine I want to use test db2, so I'll be switching my database. Hit a Control L so that I can just clean everything up. Now I can do, let's say, show tables that I have inside that database, and you can see I have a product table. Let me do a select star from product. Okay, and now you can select star from products, I believe, and this is one particular record that I have inside my table. Okay, now let's try to modify this particular piece of column piece of data that we have. Let's try to modify the price from 5 to 50. Okay, let's say the price of pen is right now changed from ₹5 to 10 rupees or 50 rupees. Okay, then how we can do that? Let's say begin the transaction. How can I begin the transaction in MySQL? Maybe I can just write begin, or I can just write start transaction. Okay, and this is how I can just start the transaction. And once my transaction has been started, I'll just query it one more time. Let's say I'm querying the data, and you can see I have this piece of data. Now I want to change the price, so I'll do update products set price equal to, let's say, 10 rupees. From 5 I am updating it to 10, where the ID is equal to 1. Okay, now let me just make a query again, and you can see right now the price is changed to 10 and previously it was 5. Now let me open another terminal window. So new window, let's say, and imagine this is another connection, and this is gonna be another session or another transaction. Treat it like that. Imagine this is T1, this is T2, and now again here also I want to connect to my MySQL database. I'll clear this up by hitting Control L. I'll zoom this by hitting command ++, and here I will do the same thing. First of all, I will switch to, can I just do Control L? Okay, can I just switch to, let's say, use test db12, and now I want to show the tables, and you know that inside this database I got a table called products, and I'll do select star from product. Let me just do one thing. Let me just begin the transaction. I can either say start transaction to start a transaction, or I can just say begin, and right now my transaction has been started. Right now let me just do a query like select star from products. Now what do you think? If I'm going to execute the query, what value I will see here in this transaction? Should I say 10 because previously the price was 5? Then I have ran a update query, you can see over here, and this update query changed the value from 5 to 10. Now if I'm gonna do a select star from product in the transaction 2, what value you are basically expecting? Anyone? If I'm gonna run this query, you're gonna see 5 or 10?
5.
5. Why you are saying 5?
Uncommitted.
Exactly, we haven't committed the data yet, right? So now Okay, hold on. I'm getting something on. Oh yeah, not committed, Pankaj. Correct. So right now, let me. Okay, it is basically products. Okay, now I can see the price is still 5 because the transaction 1 has not committed the data yet. Now if you're going to do a commit here, right, now if you're going to run the same query, you are still getting 5 here. Why you are not getting 10? Because there is a read phenomena, there is an isolation label that MySQL is using. Okay, I'm gonna show you what isolation label it is using. Don't get mad, we'll come back to this and we'll understand everything. You can see if I'm gonna do like, you know, select @ isolation label, and if I'm gonna I think transaction isolation @ and transaction underscore isolation, and you can see it's called something called repeatable read. So this is the default isolation label that MySQL uses. Now what is this repeatable read means? Repeatable read means if you are in a transaction right now, if you're gonna run this one more time, okay, you're gonna see the price has been changed to 10, but previously it was giving me 5. Why? Because I have opened a transaction, and inside that transaction I was keep reading the value. For an example, you can see right now I'll begin the transaction again over here, and now I will query the data. Okay, now the price is showing me 10, no problem, right? But here again I will just update the product to, let's say, price. Now I will change it to 5, back to 5, or let's say back to 55. Do enter. Now it is modified, but right now if you're gonna look at over here, now it is still saying 10 because the default isolation label for MySQL is repeatable read. And what do you mean by repeatable read? Repeatable read means as long as you are inside a single transaction. Here I have created the transaction, so inside this transaction, as many times you're gonna fire a query, you're gonna get the consistent data or repeatable data, even though the data has been changed by another transaction like this. I have changed it to 55. Now if you're gonna look at over here, the price is 55, but this 55, this guy is not populating here because I have begun the transaction already. I might have doing some read operation, some write operation on top of this price, but like, you know, this price that I'm using inside my transaction is 10 because when I started the transaction the price was 10. And even though it has been committed to even though it has been changed, like, you know, if I'll commit the value even, right, still if I'm going to do a select star from product, you're going to see 10 here because I am inside the same transaction and this transaction has not been completed, and when we started the transaction the price was 10, and the default isolation label for MySQL is repeatable read. And what do you mean by repeatable read? As many times you're going to fire the query, the data will be consistent throughout the transaction. But once you're going to come out of the transaction, if you're going to do commit, or maybe if you're going to do roll back, whatever you're going to do, now if you're going to fire the query, you're going to see the price has been changed to 55 because we are out of the transaction. And right now if you're going to begin the transaction one more time, then again this particular price will be keep on using that in our transaction. So this is what you mean by a repeatable read, which is the default isolation label in MySQL. If it is not clear, forget about it, we will come back to this. Now repeatable read is one of the isolation label. Okay, so now I will be talking about the first isolation label. Let me just do a Control L to clear it. Control L to clear it. Okay, now we will do one thing. We'll learn about an isolation label called read uncommitted, right? So let's say, as you can see right now, if I'll come to here to this, you can see if I'll do select @ transaction isolation, you can see the value here is repeatable read. So you know that here I have opened a terminal, this is a session. Okay, here I have opened a terminal, this is a session. So in the session label, the default isolation property which has been set by the MySQL is repeatable read. Okay, so let's say in global label, if you want to see the what is the global isolation label, this is also repeatable read. If you want to check that, you can just do global dot, and you can see it is also repeatable read. So now what I will do in the session label, I will change the transaction isolation label. I have different types of isolation label, like repeatable read, one you have just seen. Just like that, we have read committed, read uncommitted. It's very simple, right? Read uncommitted, read the uncommitted data, read committed, only read the committed data, right? Like that, a lot of different types of transaction labels are there. Isolation labels are there. Now we're going to be changing the isolation label of this particular session. So we'll do set, let's say set transaction, someone needs to mute, set transaction isolation label. Let's try to use the isolation label called read committed, okay, or read uncommitted. Okay, and I want to set not to the global label, to the session label. Like for this session, I will read everything with this isolation label. I'll tell you what do you mean by this isolation label. So I will set this to session and I'll do enter it. Now it has been executed fine. And if I'll just use this same query again, you can see right now the transaction isolation label, I have changed it to read uncommitted, and I can do the same thing for this session as well. Okay, now I'm setting the isolation label to read uncommitted, and it is changed to read uncommitted, right? Now Control L to clear it, Control L to clear it. Now let's try to understand what do you mean by this particular guy that we have written called dirty read. Okay, let's try to understand with a diagram first, and then we'll go back to the practical. Okay, so what do you mean by dirty read problem? Imagine you have a table, the product table, the same product table. We got product 1, there is a product called pen, price is 10, there are 50 stocks are available. Another products are there, let's say number 2, product name is marker, price is 20, and quantity is 100, right? There are 100 stocks are available. And this is my product table. And now there is a transaction 1. The transaction 1 starts here, imagine the begin transaction. Okay, and now the transaction 1 is selecting the product name, the product price from the product where the PID equal to 1. So it will give what? Pen and 10, right? This will be the output of this query. Product name will be pen and price will be 10 for the ID 1. Okay, very simple. Now what we are doing, we are updating the product and setting its price to 20. For the product 1, now the price will be changed to 20. You can see we have modified the value from 10 to 20. Now imagine in the same time, there is another transaction getting started. Okay, and again the transaction is begin here. Now imagine that this transaction is getting executed with this transaction, and this one is doing what? It is just selecting the P name and the price into quantity. It want to see, like, you know, what is the total stock price available. So it is doing 50 into 20. So price into quantity. So what it will do, now the price has been changed to 20, right? And the quantity is 50. So 50 into 20 is 1000. This is what we will get. Now you can see the value that we'll get out of this query when it runs. P name will be pen and price into quantity. Now price has been changed to 10 to 20 by this transaction, and 20 into 50 will be 1000, right? And now it will, let's say it will do the commit, right? So things goes good. Now my transaction 2 over. Now my CPU switches to transaction 1. Now what transaction 1 will do, it will roll back. Now think what will happen. Now this value, this is like, you know, this is useless. It will be rewarding it back. Now the price is 10. Now think, you are generating a report or you are generating some PDF by reading this particular value, and your PDF says pen and total stock value which is available, total stock price which is available is 50 into 10, there should be 500, but in your PDF, in the report that you have generated for your client, it says 1000 because of this guy. And now this price here is basically a read, like, you know, it's a dirty read. This price we have read the dirty data because the transaction 1 has been rolled back. So what should we expect? We should expect pen 500, but we got paying 1000 because of the dirty read done by the transaction 1, and the transaction 2 was reading the uncommitted data because it did roll back, right? It did roll back the changes. So when it modified that particular data, we have, we read it. So what we basically mean by this, when you read the data in an ongoing transaction, you can imagine when the transaction 2 was going on, we read the data on an ongoing transaction, which has been written by another transaction. Now you can see this 20 has been written by transaction 1, right? When you read data in an ongoing transaction, imagine transaction 2 is your ongoing transaction, and it is reading some data which has been changed by another transaction called transaction 1, and it uses this value that has not been committed yet. The transaction 2 have used an uncommitted value because the transaction 1 rolls back the value in the end and we got inconsistent data. Okay, so this is what the problem is. So now you can see this price that we got over here, that's what we called a dirty read, and the dirty, we have read a dirty price, and in transaction 2 we are performing operation over the unsaved data or a uncommitted data. You understand this, right? Because this 20 value was previously not there. Previously the value was 10, but we read this particular 20 value which has been done by the transaction 1 and it has not been committed. Okay, but still we have used the value in the transaction 2 and which got us the problem. Now let's try to understand it in practical. Okay, now imagine we are going to let's say we'll start the transaction. Okay, let's say we'll query the data. So let's start from products. Okay, now let's say this price is right now 55. Okay, now let me just change this price to let's say 5. Okay, now let's say the price I will change, right? I'll use the object query. Can I just use my, because I have written the object query previously. Now I will change the price to 5. Previously it was 55. Now I change the price to 5. Okay, I have begin the transaction. I have done a query. I have changed the price from 55 to 5. Now I have not committed the data yet. But if you're gonna see, if you're gonna come over here and if you're gonna begin the transaction, and now let's imagine here I'm just reading the data. I can do select star from product, right? And you can see what I'm seeing is 55. Now see the problem. The 55 has not been committed yet. Previously the value was 5 only, right? I told you, no, previously the value was okay, hold on. We have changed the value to 5, right? Okay, 1 second. Can I do a select star from, we have changed the value to 5. I should see the 5 here, isn't it? Because the value has not been committed. Can I just do a rollback and clear?
Maybe, yeah, maybe we have set the transaction at session level.
We will see. We'll see. Transaction isolation is read uncommitted. Yeah, it's read uncommitted, right? So let's say start transaction. Let's say I will start the transaction here. Now I will do what? I will do a select star from product, right? Let's say products. Yeah, now you see. Now the price I'm seeing here is 5. Why I'm seeing the price here is 5? Because I have changed the value to 5 here inside the transaction. Imagine this is your transaction 1 and this is your transaction 2. What value you should be expecting here is 55. This was the base, right? But now imagine I have started a transaction and inside this transaction, I have changed the value of 55 to 5 where the ID is 1. Now imagine this is a unsaved data. This is a uncommitted data. What happens? This guy will go ahead and roll back the changes. Now I am actually seeing this data. Imagine I'm generating some report or something and I'm doing like, select, let's say name of the product and the total stock value, let's say unit into price is total stock value. Let's say total value from the products table, right? If I'm going to do that, see the total value that I'm getting is 250. Let's say I'm generating this report and giving it to my client, and then what happens, this guy roll back the changes. Okay, now what will happen? What is the original value? If you're gonna do a select star from product, the price is 55. But look at that, what we are calculating. We're calculating over a price called 5, which was a unsaved or a uncommitted data made by the transaction 1, and we are using that particular value and generating our report, giving it to our client. And what our client will do, let's say we'll do a commit, and what our client will do, he'll do the same thing. And he is right now getting the total value of 2750, but we have written this particular value in our report called 250. Now see the changes, see the difference, see the mess. And this is where we have read a dirty value. The dirty value was your price, because price value we are using, and the price value we have changed in the first transaction here using this update query, and this data that we have changed has not been committed and rolled back later by the transaction 1, and this price value has been used by the transaction 2 to do some queries, and it has used it, and then we got a mess over here, right? This is what the dirty read basically means. Dirty read, again we'll read that particular definition. Can we go back to the slide and read this? When you read data in an ongoing transaction which has been written by another transaction that has not been committed yet. So transaction 2 is reading some data using a query, and that data has been changed by the transaction 1 but has not been committed yet. It is rolling it back later, and we are using some unsaved data or uncommitted data. This is where the problem comes, and this particular problem comes with the isolation label called read uncommitted. What is the isolation label that we are using right now? Okay, read uncommitted. Read uncommitted means what? Reading the uncommitted value. Okay, read uncommitted, the dirty read problem will happen in this isolation label called read uncommitted. And read uncommitted means no isolation. Any changes from the outside the transaction will be visible to the transaction. Any other transaction is running, any changes it will do, that will be visible to your current transaction. Changes will be visible irrespective of the values has been committed or not committed. Even the values are not committed in the transaction 1, still the values are basically visible to another transaction, which actually created the mess over here. Now tell me guys, if it is making a little bit of sense. Yes? No? I messed it up? I'm sure. Okay, making sense? Lakshmi, Lavanya, Mahadevi, Chaitanya?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Sure, no, Akhil?
Yes, sir.
Okay.
I mean, only one thing didn't understand, and read the default one. I think read.
Default one is unrepeatable read. We'll be going into that. I am going into that. Now, how I will be solving this particular problem? Okay. Now, how will be solving this particular problem? What is the current isolation label I'm using? Read uncommitted, right? Read uncommitted is the current isolation label. Let me do a Control L to clear this. Control L to clear this. Now, to solve this, guys. Here the problem that we are having, we are reading the uncommitted value. Now to solve this, we will be using another isolation label given by our MySQL, and that is called read committed. Now I will go to here first in the transaction 1, and let's say set the transaction isolation label to read. This time I don't want to read the uncommitted data, I want to read the committed data, and I will also make sure to set it not to the global label, to the session label, to this, and I will do enter. We have a problem because committed spelling, you know how good I am with my spelling and everything, and then I'm also going to change the same thing over here. Okay, committed with double T. Okay, now I'll do Control L to clear everything here, Control L to clear everything over here. Now I can just do select transaction isolation, just to see whether the values has been changed. And you can see right now the transaction, the isolation label that we have is called read committed, and I set it to the session label only, right? And the same thing, if I'm gonna copy this and paste it over here, I want to make sure that here is also I'm using the isolation label as read committed, right? Making sense. Now I'm doing a control L here, I know I'm using the read committed right now, and this read committed isolation label will basically help us not to have the dirty read problem, because we will be only reading the committed value. The name says itself. So now let me show you with an example. Let me say I'm going to begin the transaction, and I will basically use what? I will do a select star from products. Now you can see the price is 55. Now I will change it to 5, let's say. Now I'll do a update query. I already had an update query. Can I use this? And let's say price, I'm going to change it to 15. Let's say 15. This is the price I'm changing. I'm updating. Now if you're going to see the price that I have changed it to select star from, I have changed it to 15. Okay, previously the price was 55, and in this transaction I've started a transaction and I have ran an update query and I've changed the price to 15. Okay, making sense. Now I have not committed the data. Imagine in the same time transactions 2 started, and here what I'll do, I will start the transaction, let's say. Either I can use start transaction to start a transaction, or I can just say begin to start a transaction. And now here what I'll do, I will, let's say I will just do a select star from. Okay, I will just do first I'll just do a select star from products. Now look at that, the price I'm getting is 55, but I have changed here the price to 15. But the problem here is that this 15 I have not committed, right? I have not committed this particular data to my database. That's why it is an uncommitted value. And what is my current transaction label? You guys know, right? My current transaction label is read committed. So this guy is reading the committed data, which is 55 here, right? Now if you're gonna see, if you're gonna run the same query that you have ran before, if you're gonna do unit into price, it is going to calculate it on top of the committed value that we had, right? Now if you're gonna do enter, you can see the value is coming as 2750, because you know, maybe someone will roll back this particular value and this 15 will go away, right? And we need to make sure whatever the committed data that we have for that particular column, we'll be using that particular data, even though any transaction is modifying this particular data and has not been committing it, we will not be using it, right? We'll be only be using the committed data here, right? So this is the use of read committed, and this is going to help us to resolve the dirty read problem. Okay, now imagine I'm going to be committing the data right now. I'm going to be committing it. Then what will happen? If I'll be committing it, right? If I'll be committing it, then if you're going to do a select star of price, or let's say select star of product, now you can see the value has been changed to 15. This basically leads us to a different problem, isn't it? Now what is the problem? Previously when you did a query, okay, you are inside the same transaction, you did a query and the price was 55. Now after 5 minutes, you did again the query, and right now you are getting prices 15. See, we're inside the same transaction only, but we ran the select star from product couple of times, but our dirty read problem got resolved. We are reading the committed value, but the problem here is that previously the value was 55, now the value has been changed to 15, right? So the values are not repeating. So this is the non-repeatable problem. This is the non-repeatable read. Okay, so maybe let me just tell you with a slide right now. So this basically solves the dirty read problem, but creates another problem, which is the non-repeatable read. Now I'm going to be showing you a slide. Okay, non-repeatable read. So what do you mean by non-repeatable read? Imagine you got a product table, okay, and inside the product table you got a transaction 1. Let's say the transaction 1 is starting over here, begin transaction, right? And we are selecting the P name and price from the product 1. Now it is giving us pen and 10. Obviously the P name is pen, 10 is the price, so I'm getting this as a output. Perfect. Now imagine there is a transaction 2, and the transaction 2 is doing what? It is beginning the transaction, okay, and then it is updating the product price to 20. Now this 10 has been changed to 20 by this transaction 2. Now imagine it has committed the value. And now if our isolation label is read committed, then again in the transaction 1, if we'll run the same query, we'll read the committed data. And obviously the commit has been ran by the transaction 2, so 20 will go over here, and whenever we will again run the same query, we will get the output as pen 20. But see here, this is inside the same transaction. Inside the same transaction, I am running this couple of queries and I am getting different data, right? Here I got a different data, here I got a different data. So the data are not repeatable. The data are not constant. So these are non-repeatable data. Inside the transaction, I always want the data to be consistent, but the data has been changed by another transaction over here. Okay, now if you're gonna ask me, Abhilash, what is the difference between the dirty read and this read? Then here also we are reading the dirty data. No, you are not reading the dirty data. In the dirty read, you used to read the uncommitted data or unsaved data. But in the non-repeatable read, you are reading something which has been committed. This is a valid piece of data. This went to your database, but this happens in between a transaction, in between an ongoing transaction, and is impacting it. You can see same query but different results. It is non-repeating, it is not repeatable. Okay, and this is the problem of the read committed isolation label. Okay, this is the problem of the non-repeatable non-repeatable data. I told you, we got some problems like dirty read. This is the read phenomena. We talk about that. Non-repeatable read is something that I'm discussing. What do you mean by that? In the non-repeatable read, every time you run a query, you got some different data which is not getting repeated, because inside your transaction you need the data to be consistent, but the data is not consistent over here. Whenever you are reading it for multiple times inside the same transaction, same queries are giving different data, right? So how will be resolving it? Let me do a control L. To resolve this, you have to set a isolation label. Can I use this guy? And the isolation label will be I think non-repeatable. I think non-repeatable. I think repeatable read. Okay, now if you're gonna see, now I have changed it to the repeatable read. This is the default of MySQL. So what this guy will do, let me just change this to repeatable read. Control C, Control V, enter. Now what this guy will do, now here also let me just check one more time if it has been set properly. Repeatable read is set. Now Control L, Control L. Now imagine this is transaction 1, this is transaction 2. So inside the transaction 1, I'll begin the transaction. Okay, now I'll do a select star from products. Okay, now imagine the price here is 15, right? So if I will do select star from product, thousands of time, I should get the price is 15, even though the data has been changed by another transaction and has been committed also. For an example, here I will begin the transaction. Okay, I will run an update query. I'll do select star from products. Okay, now the value is 15. I'll do update products set price is equal to, let's say, 100 rupees, right? 100 rupees where ID is equal to 1. Now this transaction is changing the value. You can see now the value has been changed to 100. Now I'm going to be committing it, right? Now the value has been permanently changed in the database. If you're going to see in the database, if you're going to do a run, the price has been changed to 100 because right now I have changed it to 100 over here by the transaction 2. But inside the transaction 1, because the transaction has already been started, this price that we had during the beginning of the transaction need to be consistent throughout the transaction. Okay, now if you're gonna do if you're gonna run the same select query, you can see you're gonna see still 15. Okay, what about if you're gonna see do some query like this? Select star from, let's say, total stock. I want to find, let's say, name of the product, and tell me the total stock unit into price is total stock amount, total amount that I have, total number of stock which is available, where ID is equal to 1, right? What happened? Where ID is equal to 1, is total amount. Select star from name.
Go to star, sir.
Oh, no, this one you were saying?
No, select, sir. Select name.
Oh,
from unit price.
okay. Select name and unit price as this one from products, right? From
Right.
products. Enter, and now I'm getting 750. I'm getting 15 into 5, 75, 750. I'm getting 750 over here. It is not giving the committed value, which is 100. But once you're gonna do, let's say you are generating a report, then the data need to be consistent, right? You should only care when you started this transaction, this is what they are inside the database, and you generated the record after that, right? But after starting the transaction, before committing the transaction over here, if something happened outside of the transaction, you don't want to bother about that, right? So the data will be consistent. Now if you're going to do a commit, I think over here, or if you do anything over here and you come out of the transaction, now if you're going to do select star from again, now you are getting 5,000 because now we are reading the new value, because when we will, even though we are running this query, it is running under a transaction, even though we are not starting a transaction like writing start transaction or begin. Now if you're going to run this query, you can see now the value is 5,000, because when we started this transaction, the price which is there inside the database was 100, right? And you know that the database price is 100. Now we're generating with that. Now if there is a transaction starting and changing the value, we will not be bothering about that if we are inside a same transaction. So one point you have to remember, if you are inside a same transaction, imagine you have started a transaction over here, doesn't matter how many times you run a identical query like select star from or whatever query you are running, the data you should get, it should be repeatable. Okay, that data should be consistent, and the data will be consistent throughout the transaction, and that is what we call a repeatable read. And by default, MySQL isolation label is repeatable read. Okay, if you're gonna go to the slide that I have got here, okay, the isolation label is called non-repeatable read, and for that you have to use repeatable read. The transaction will make sure that when a query reads a row, that row will be remain unchanged while it's running inside the transaction. It will not be changed. So today we talk about 3 isolation label. We read about read uncommitted. Read uncommitted is the the first isolation label. That means there will not be any isolation. Any change outside of the transaction will be visible to the transaction. Any ongoing transaction changes will be visible irrespective of the value has been committed or not committed. And you understand that in this isolation label we'll have the dirty read problem, because we'll be keep reading the value which has been done by another transaction, but maybe the transaction which has been started, and maybe the value that the updated value that we are using here inside another transaction could be rolled back by the transaction 1, and in that case it will lead us to get inconsistent data. So this is the dirty read problem, and that we will get in the isolation label called read uncommitted. And then we may have the repeatable read, non-repeatable read problem. For an example, now if you're running the same select query, similar kind of query, if you're running again and again, the data need to be consistent. But here in the transaction 1, whenever we're running the similar query, we're getting different data. Why? Because another transaction has committed the value. Okay, has committed the value, and here we are reading this particular values which has been already committed by the transaction 2, and this particular problem will occur with an isolation label called read committed, where the ongoing transaction only can see the committed changes of the another transaction. This will basically remove the dirty read problem, but it will create the repeatable read problem. Okay, whenever you are using read committed, you will get both the dirty read and the non-repeatable read problem. But here in the read committed, the dirty read problem will go away because we'll be reading only the committed data, but the non-repeatable problem will not go, because if you're going to execute the similar kind of query as the data has been committed by another transaction, we'll be keep getting different data. Okay, and then one more we have discussed, which is called repeatable read. This is going to resolve your dirty read problem and non-repeatable read problem, and this is going to make sure that inside the same transaction, even though you are running thousands of query, for thousands of time, every time you run the identical query, you will get similar data, right? The data which has been only be made by whatever the changes we are making inside the transaction, inside one transaction, that data only we will see over there. Okay, any other transaction is running outside, those values will not be impacted. Okay, these three things you just go ahead and just try to do the practice. And I don't want to take a longer session because I know transaction is a fairly complicated topic, guys. I don't want to get into so many things. I'm just giving you as a prerequisite. I hope whenever we will go back to Spring and we'll start using our transactional annotation, we will be making sure the things are easy. Okay, because you will be, as I said, you will be seeing the similar kind of thing right there. And I don't want to do something blindly, because if I'll do something blindly, then obviously it will create problem, right? Because it will not be understandable. So I'll make sure, I'm just making sure that if you have read the same thing in your BTech or in your engineering or in your masters, I'm just repeating the same thing, because inside the transactional annotation, we got something called isolation. And now these things will make a little bit sense to you. Read committed, read uncommitted. We have something called repeatable read. We got serializable. We'll talk about this in the next lesson. Okay, but for now, this is it. Okay, tell me if you have any questions.
What is the default value for this? Is it repeatable read, right?
Any other questions from today's lesson, Akhil?
I'm just saying one thing, when you're doing the read uncommitted, right? So that time the read problem will occur, but it will read only the uncommitted ones, right? Even if committed, those ones will be read also.
Come again, Akhil.
Like if you do read uncommitted, right? So another transaction has either committed or non-committed, but still the values will be read, right?
Correct. This is what the dirty read problem will happen in the isolation label called read uncommitted, and in the same isolation label, the non-repeatable read will also happen. Okay, both the non-repeatable read and dirty read problem will happen whenever you will be using the read uncommitted isolation label. But whenever you change it back to the read committed, you will be only reading the committed value. So dirty read will not be possible, but still you will be getting the non-repeatable read, because once you're going to do a commit, right, the data has been committed. So if you're going to execute the query, then you will get a different data. Once commit, you'll get some different data. So maybe people here get confused. They will ask, like, what is the difference between dirty read and non-repeatable read? Then make sure there is only one difference. They look similar, but in the dirty read, the transaction 1 is getting rolled back. So the transaction 2 is using some uncommitted data which has been marked by the transaction 1. Here you can see there is some update is happening. It was changing the value 10 to 20, and transaction 2 is using this 20, which is the uncommitted data, because this 20 is getting rolled back by the transaction 1. Okay, and the transaction 2 is performing operation on top of the uncommitted data, which is leading us to the dirty read problem, right? But if you talk about the repeatable read, there is a difference here. Here you can do the transaction 1 is performing operation over a committed data. Right now the price has been changed to 20, but this has been committed. But as it is committed, now the dirty read problem, this is not a dirty read problem. Why? Because previously the value has been rolled back. Whenever you perform operation over a uncommitted data or unsaved data, that is called dirty read. But if you are performing operation over a committed data which has been committed by transaction 2, then you will get different result, but this is not dirty, this is unrepeatable. Why? Because same query giving you different data, but this data is coming because of a commit has been done by the another transaction. Okay, so if you're gonna see this particular diagram that I got from Google, the read uncommitted, if you're going to using this, the dirty read is also possible, non-repeatable read is also possible. But whenever you're going to do read committed, the dirty read will go away because you'll be reading only the committed data, but the non-repeatable read is still possible. Okay, but if you are using repeatable read that we have used at the last of the session, here whatever we have done, if you're going to run the query for thousands time, you're going to get the same data if you are inside the same transaction. And this particular isolation label that we have called repeatable read, this will solve the dirty read problem and also the non-repeatable read problem. But what is serializable? We'll talk about this tomorrow. Okay. Now, okay, tell me.
data inconsistency will happen in both read uncommitted and read committed, right?
Yes, data inconsistency will happen. You can say that.
But not in repeatable read.
But not in repeatable read, because in repeatable read, obviously every time you'll run the query, it will be identical. It will be same. Okay, it will give you a consistent data. Do this one time by yourself, Akhil. Things will make perfect sense.
Yes, got it.
Okay, and once you understand this much only, then only these things will be easy, Akhil. Right? This thing you'll just do, without seeing anything. Anything that you have inside the transactional also, if you go inside this, if you're gonna see the default, don't say this, I'm gonna talk about this tomorrow. If you're gonna see here, this is the propagation isolation, right? Now if you're gonna go to this constant, everything that you have written over here, right? Isolation read uncommitted, isolation read committed, isolation repeatable read, everything will make sense, right? See it one time by yourself by doing it. I don't know how much sense it made right now, but if you're going to be doing it for, this is not Spring, guys. Whatever we have discussed, we have just discussed some prerequisite that I'll be needing whenever I'll be writing this, because I don't want you to get bypass this particular topic by just writing the annotation and not explaining this. Okay, so make sure to do this by your own so that it will make sense. Yeah, any other questions, guys? Is it making sense a little bit?
Yes, Abhilash.
Lavanya, sure, huh?
Yes, Abhilash, for at database level, it is understood. But see, if you have other transactional like read and committed, if you override it, for that particular section will be...
Yeah, that we will see, Lavanya, that we'll see. I have not discussed anything.
Okay.
Prasad is saying, making sense. Okay, thank you very much. I'm planning to give this transactional, these 2-3 sessions for free to everyone. Yeah, someone has questions. Yeah, Chaitanya, go ahead. Long time, Chaitanya. Yeah, tell me, Chaitanya.
You told that global session as well as session level globally, right? Isolation we can set session level as well as globally.
Correct.
Session level means global level.
Global level means in global level you can have one isolation level, and in the session level you can also override it in case it's needed. In case it's not needed, whatever you are setting in the global level, you can go with that in the session level as well. Okay, but I was
session level so that you the same thing in the other
transaction. Correct.
So what is different exactly global level? Session level also applicable to all the transactions.
No. Session level will only be applicable for this terminal, this transaction. If I'm writing session means any terminal that I'm creating, this is one session, right? The scope will be only here inside this. Global means any terminal that you will open, one label you'll set over here. Correct. That's why I'm just trying to change it over here. Just don't want to mess things up, because maybe sometime I'll do something and then it will give me some wrong data, and I will just go mad at the time. Why did I change this? Because I don't remember. If something that I do today, tomorrow I'll not remember this. So yeah, changing it accordingly. Yeah, and any other questions? Prabhat, any questions, sir? Hi.
Actually, I have to go through this one, and I have
Yeah.
a question, and I will go through and
Sure. Please ask me tomorrow, Prabhat. Okay, please ask me tomorrow. Guys, everyone, please go through this and ask me tomorrow. And tomorrow we'll do some more things, maybe couple more things, and the things will make sense to you guys, right? This is not Spring. Just remember this much. This is some basics. Yeah.
one thing.
Yeah.
When you are using the isolation, in the DB side, does it create a virtual data set or in caching?
So you are saying it has been changed in cache, or this has been changed to the database itself? Is this something? It is directly making changes to the database, Prabhat. No cache. But here there are things. There are various things over there. Primary memory, secondary memory. Guys, let me tell you this thing. All this read phenomena you are seeing, all this isolation label that you are seeing, this is like, very nasty problems. And if you're going to set the isolation label, this is going to lead list towards the performance issue. Okay, because you'll be blocking the transaction. So you need to be very careful whenever you're choosing some read phenomena. And there are different types of locking mechanism which is getting used. I want to show you a problem. I want to show you something before I wrap up. Imagine Control L to clear this. Control L to clear this. You want to see how the locks are getting used. Now see, for an example, Control L, and I'll just start a, I'll say begin. I'm starting a transaction, and I'm doing select star from products. Okay, and now products are, let's say I want to update the query. Where is my update statement? Okay, now I want to change the price to 15. Okay, now the update has been done. Now I have not committed this transaction, right? Now here I will begin another transaction, and here I will try to update the price to 110. Okay, and do enter. Now look at that, it's stuck. It's stuck because this guy, this transaction has locked that particular row. Okay, there are different types of locking mechanism here in database. Like it can lock a row, it can lock an entire table, right? Now I can see it can keep on waiting for some time, then it will throw me a error message. It will say that I will wait to commit this transaction. Once this transaction will be committed, then only this update will happen, right? Now if I'll show you the situation, right? Let's keep talking for, maybe the default time is set to 50 seconds. Maybe after 50 seconds, you'll see a beautiful message here that, well, I am still waiting that you need to commit this transaction that you have begin. And if you're not committing it, I'll keep on waiting to make sure to this. See now, lock wait timeout exceeded. Try restarting the transaction again. Okay, now it is waiting till this transaction to be committed. Database is using locking mechanism. So there is concept like database locking. Now how the data is getting saved in cache or in RAM or in your secondary memory. That is also another database topic. Maybe we can see that in some other time. But you can see, like, if I'm gonna do I will run the same query again, but this is waiting. But let me just try to come to here. And let me do a commit, enter. Now you can see it has changed the data to, let's say, 110. Now if you want to see that, right, it is going to give you 110. So you cannot perform multiple operations. There is some locking mechanism going on over here. Don't want to get into that, but later I'll show you. And whenever you're going to have this kind of problem, right, I have written some, I know that you're going to have this kind of problem. I have written these commands that I have used today. I'll be giving you. And imagine, guys, whenever you're going to have that kind of problem, imagine there is, you are starting some transaction. This problem is very frequent. You're going to have this. You're going to do begin transaction. Okay. Now the transaction has been started. Now let's say you are trying to, you are, let's say, updating something, and it is stuck. Because this transaction has not been committed yet. Now it is stuck. Now now it is going to give you some error, right? Like the things has been stuck because there is another transaction, which is this one, which has been already open, doing some modification, and you cannot modify the same row which ID is 1, because that thing we are modifying here, and it is locked. And for that kind of situation, if you want to avoid it, make sure one transaction you are committing, or you just run this particular query, this one, see the process list, and just kill the process, right? I'm going to give you this query or this commands. So here, once, let's say, what you can do, let me just wait for the error message. Once you're going to get that, you're going to see the entire process list. Right now it's saying is timeout. Show me, like, why it is happening. Show me the full process list. You can see there are few things going on over here, and someone should be waiting. Okay, waiting for the empty queue, this one. Let's say if I want to kill this, you can just do which one is doing the update query, localhost info. Can I just expand it a little bit? Okay, you can see, you can just have your own the particular process which is going on. You can just have that. And the other one, let's say I want to kill 5. Okay, let's say kill 9. Okay, kill, I think 5 that I'm using, kill 10. kill 11. Okay, query execution interpreted. Okay, kill 12. Okay, current database test db2. Okay, now let me just run that update query one more time, and you can see right now it's updated because the other process that we have created previously, we have killed it. Right now that transaction has been done. We have killed that particular transaction. So make sure that you can use this process list whenever you're going to have a blocker. See all the processes running and all the unnecessary processes, just kill it, just like this. Okay, I'm going to ping you the commands, guys, in the Skype today. That's it. Any other things? Yeah. Lakshmi is saying, what if one is update and one is delete? Oh, okay. If you're going to talk about the insert and the update one, always the update means non-repeatable read. Whenever you talk about insert or whenever you talk about delete operation, that's where something called phantom. Phantom means ghost, right? Ghost read. The row can appear anytime, the row can disappear anytime. Tomorrow we're gonna talk. I don't want to get mad with all these things. Yeah, okay. I'll see you guys tomorrow then. I am stopping the recording from here.
Recording stopped.
Anything you want to ask? Or I can just wrap it up. Akhil, Lakshmi, Lavanya, Madhabi.
Is there any relation between the flush mode in the JPA Hibernate with the isolation levels?
There is, see, this is the right question. Maybe, okay, I'm recording it from my Camtasia at least. Maybe you would have asked me this question previously when I was recording, Prabhat, because it's a very nice question. There are differences. The way the isolation label has been implemented by different databases. Like if you're going to see the MySQL, Oracle, Postgres, they all, like it's pretty much similar, but the way the engineer of that particular company have implemented the things, maybe you can see there are small kind of differences are there. Maybe I have installed Postgres. Just for the reason for that, I'll be showing you in the next lesson how the MySQL isolation label and the Postgres isolation label different. But if you're going to see the isolation label, this is not something that you have in Spring. You also have the same thing in JPA. You have the same thing in JDBC as well, and the things are pretty similar. Pretty much same, Prabhat. But in database label, you have to understand which database you are using, and maybe isolation labels just tweaks a little bit with respect to their behavior. But I'm going to be showing you by comparing the MySQL isolation label and Postgres isolation label in future. Okay.
Okay.
Okay.